For this video, we'll be doing lesson 5-1, part 1, where we look at least common multiples. So, to start that, a multiple is a product of a number and any non-zero whole number. So remember, multiples are like when you're multiplying something and you're kind of essentially counting up by it. All right, a least common multiple is the lowest multiple that is common to two or more numbers. So the least common multiple is going to be the lowest multiple that is in common for both numbers that you're comparing, okay? Or if you're comparing 3, it's going to be the smallest number that is a multiple of all 3 of those numbers. So there's a couple different ways we can do this. One way you can do this to find multiples is you can make lists. Excuse me. So this says, today the school's baseball and soccer teams had games. The baseball team plays every 7 days. The soccer team plays every 3 days. When will the teams have games on the same day again? So what we're going to do is we're going to make a list of multiples of 7 and a list of multiples of 3 and then figure out what the smallest number is that they both have in their list. So 7, 14, 21, 28, 35, 42, and that's going to keep going, but we're going to move down to 3 and see if any 3 hits any of these. So 3, 6, 9, 12, 15, 18, 21. So that 21 is the smallest number or the lowest number that they both have when we start the list. So the LCM is 21, so least common multiple between 7 and 3. And in 21 days, both teams will have games on the same day again. Okay, so that's one way you can do it. That works with smaller numbers. When we get into bigger numbers, if you do lists, you're going to have to go for a long time. So it's not necessarily the most efficient way. On your homework, it will specify if it wants you to use lists or if it wants you to use prime factors. So using prime factors, we're going to remember what we did when we were making prime factor lists and doing greatest common factor, and we're going to kind of build on that. So step 1 for finding the LCM between 16 and 36 using prime factors, we're going to make some trees. So we have 16, which can be broken to be 2 and 8. 8 is 2 and 4. 4 is 2 and 2. Okay, and then we have 36, which can be 2 and 18. 2 and 9, 3 and 3. So if we look at 16 and we write that with prime factors, we're going to have 2 to the 4th power, right? 2 to the 4th power. If we look at 36, we have 2 to the 2nd, and we have 3 to the 2nd, right? To get 2, 2, 3, and 3. So when we're writing prime factors for LCMs, we're going to be using the exponent form, okay? Then, for the LCM, something that's different, you bring one of every type, and you bring the highest exponent. So when we were doing greatest common factor, it had to be things that they shared, but that's not the case for LCM. For LCM, you have to bring one of every type of thing. So what I mean by that is, if there's 2s in any of the lists, you have to bring down a 2. If there's 3s in any of the lists, you have to bring down a 3. If there's 5s in any of the lists, you have to bring down a 5. So you have to bring one of every type of thing. And you want to bring the greatest power of each factor. So 2 to the 4th versus 2 to the 2, we're going to bring down 2 to the 4th. Okay, and that covers our 2s from the list. But then we also have to bring down 3 to the 2nd because we have to bring down 2s and 3s because in our list we have 2s and 3s. Okay, then we're going to multiply that out. If you do 2 to the 4th, 2 times 2 times 2 times 2, and then you do times 3 to the second, 3 times 3, you're going to end up with 144. So the least common multiple of 16 and 36 is 144. So if you had been making lists, you would have had to go up a long ways from 16 to get to 144, right? So that's why it can be more efficient to use prime factors to help you solve that. Okay? It's the same process when they have a variable attached. You just, when you're writing your prime factor list, just like when we did this with GCF, you're going to have to add in those variables. So, like this one, we have find the least common multiple of 5a to the fourth and 15a. So 5a to the fourth, 5 can't be broken apart, right? So our prime factorization list for that is just 5 times a to the fourth, right? 15 can be broken though. 15 can be 3 and 5, right? So the prime factorization list for that is going to be 3 times 5 times a, because it was 15a. Now we need to bring down one of every type of thing and the type with the highest exponent. So we have 3's, I bring down a 3. We have 5's, I bring down a 5. We have a and a to the fourth, so I bring down a to the fourth. And then I'm just going to multiply that back together to figure out my least common multiple. So 3 times 5 is 15. A to the fourth, because we have an a to the fourth in our prime factor list. So the least common multiple of 5a to the fourth and 15a is 15a to the fourth. All right, when you're ready, go ahead and flip your paper over. We're going to switch down to the quick check, right? Because this is only part 1, so we're skipping some of those fraction parts. So use multiples to find the LCM. So that means list form, right? Use multiples to find the LCM. So between 3 and 4. So we're going to count up by 3's. 3, 6, 9, 12, 14. And I'm going to stop. No, that's wrong. 15. Miss Kale's crazy. Okay, I'm going to stop there for now. Then I have 4, 8, 12. Ding, ding, ding. I have a winner, right? That's the smallest number. So the LCM is going to equal 12. All right, so we're going to have a moment where we pause the video and you're going to work on B and C. Notice how C has 3, so you're going to have 3 different lists that you're working on. The LCM has to be shared between all 3 lists. Okay, so go ahead and pause your video and work on that. Okay, so hopefully what you had for that, the list for 4 would be 4, 8, 12, 16, 20, 24, and I'm going to stop there. 5, 10, 15, 20, ding, ding, ding. Miss Kayla has a winner, right? So then the LCM of 4 and 5 is going to be 20. All right, the next one we have lots of lists. So for 3, we have 3, 6, 9, 12, 15, 18, 21, 24, 27, and we're gonna let it just keep going for a minute. 4, 8, 12, 16, 20, 24, 28, 32, and we're gonna let it keep going for a second. 5, 10, 15, 20, 25, 30, 35. All right, so this one's like a trick question, right? Because we did those lists and we still didn't find the number. That means that what we should do is use trees. I'm also gonna tell you that if you make lists like this, and they get really long, you can switch to trees if you can't figure it out. That being said, 3, 4, and 5, right? Okay, so a tree for 3 would just be a 3, right? A tree for 5 would just be a 5. And then 4 would be 2 and 2. So your LCM is going to end up being 3 times 5 times 2 to the second. So you really are just multiplying them all together, and your LCM is going to end up being 60. It doesn't work every time. I know in all 3 of these examples, you could just multiply them and you get your answer, but that doesn't work every time, so don't use that as a trick, because that does not actually work. All right, now we're going to use prime factorization to find the LCM. So this is where we're going to use trees from the beginning. So I'll do A with us. So we have 6, oops, which breaks apart to be 2 and 3, 16, which breaks apart to be 2 and 8, 2 and 4, 2 and 2. Then you're going to set up your prime factors. So you have 6 equals 2 times 3. 16 equals 2 to the 4th, right? Then I'm going to say LCM equals, and I bring down one of every type of thing. So I have to bring down some 2 and some 3, but I want to bring down the one with the highest exponent. So I'm going to have 2 to the 4th times 3, which means that my LCM is 2 times 2 times 2 times 2 times 3, which is going to give me 48. Okay, so to show your work for these, you need to make the 2 trees. You need to have your prime factor list, LCM showing what you brought down and which exponent you brought down, and then LCM final answer. So you can go ahead and do B and C on your own. Pause your video and then we'll come back and do them together. Okay, so for B, we have 9 and 15. 9 breaks apart to B, 3 and 3. 15 breaks apart to B, 3 and 5. So 9 equals 3 to the second. 15 equals 3 times 5. Our LCM, we're going to bring down one of every type of thing, the type with the highest exponent. So we have 3 to the 2 times 5, because that covers our 3's and covers our 5's. And then we're going to do the math to figure out what that is. 3 times 3 times 5 is going to be 45. Okay, for each of those steps. All right, C had 3. You still do it the same way. So for 12, you have 2 and 6. 6 is 2 and 3. 15, you just have 3 and 5. 18, you have 2 and 9. 9 is 3 and 3, right? So now you're going to make your little list. So you can say 12 equals 2 to the second times 3. 15 equals 3 times 5. 18 equals 2 times 3 to the 2. So we have 2's, we have 3's, and we have a 5. So for our LCM, when we're pulling down, we're going to have to cover 2's, 3's, and 5's, and we're going to want the ones with the highest exponent. So we're going to end up with LCM equals 2. We're going to start with 2, and we want the one with the highest exponent, so we're going to say 2 to the 2 times 3 to the 2, because there's 3, 3, or 3 to the 2 to choose from, and then times 5. When I do that math and I actually go 2 times 2 times 3 times 3 times 5, I'm going to end up with 180. All right, last round of quick checks is going to be ones with variables. So again, you set that up the same way. You just have your variable in your prime factor list and bring it down. So 12 breaks apart to be 2 and 6. 6 is 2 and 3. 15 is 3 and 5. So when you write out your list, you want to make sure you say 12x equals 2 to the second times 3 times x, because that helps you. If you write it here with your variable just like it is there, it helps you remember to put your variable in your list. 15xy is going to be 3 times 5 times x times y. And then we're going to bring down one of every type, and we're going to bring down the one that has the highest variable, or the highest exponent. So my LCM for this one is going to be 2 to the third, no, 2 to the second. 2 to the second times 3 times 5 times x times y. Because again, you still have to represent each of the types of numbers. So we have 2s, 3s, and 5s represented. And then we needed x's and y's, but none of them had an exponent, so we're gonna have just a plain x and y. When you do that math, you're gonna have 2 to the second, so you have 2 times 2 times 3 times 5, and then times x times y, so you should end up with 60xy. Okay, you have 2 more that you're gonna try on your own, so go ahead and pause your video, and then we'll do those together. I made a ruler happen. How did I make a ruler happen? There we go. Okay, so for this one, 8 you're gonna break apart. 8's gonna be 2 and 4, and then 2 and 2. 14's gonna break apart to be 2 and 7. And then remembering that when you wrote them with your prime factors, you should have written them with your variables. So 8m to the second is gonna be 2 to the third times m to the second. 14m to the fourth is going to be 2 times 7 times m to the fourth. So when I'm bringing things down for my LCM, I'm going to need 2's, 7's, and m's. So I'm going to say LCM equals 2 to the third times 7 times m to the fourth. When I actually do that math, 2 times 2 times 2 times 7, I'm going to get 56 m to the fourth. And then for that last one, 25 is going to break apart to be 5 times 5. 15 is going to break apart to be 3 times 5. So we're going to say 25y squared equals 5 to the 2 times y to the 2. 15x equals 3 times 5 times x. So our LCM, we bring down a 3. We bring down 5 to the 2 because we need 5's represented, and that one has the highest exponent, times x times y. LCM, when you do that math, is 3 times 5 times 5, which is going to give you 75 x y to the second. We should have y to the second here, right? Y to the second. 75 x y to the second. All right, that wraps up part 1 of lesson 5-1.